lesson 10. This is over section 1.4 parts C and D. But before we start that, let's go ahead and review what we learned yesterday. And of course, your homework was over a lot of it. We have 4 arithmetic operations that we can use with functions. One is addition. We have subtraction, multiplication, and division. All of these are going to have the same domains as their original, with the exception of the division piece. You want to be very careful because when you divide, you cannot divide by some value that is equal to 0. So there may be some extra restrictions on our domain for the division. We also discussed compositions, a function that is being inserted into another function. And here up on the board I've got some examples of that where we took f composed of g, where f of x was 2x and g of x was x plus 7. We simply substitute in the x plus 7 where the x is in my f function, and of course distribute, combine like terms, simplify things down if you can. In most cases, you will not have the composition of f with g being the same as g composed of f. Occasionally that might happen, but do not assume that is going to be the case because in the vast majority of cases it is not going to happen. Now that brings us to today's lessons. We've talked about some relations, and now we're going to look at relations and their implicitly defined functions. Sounds really fancy, but it's really not all that difficult. Let's begin by talking about relations. Not all relations are going to be functions. Remember, a relation is when you have a set pair of ordered numbers. So an x and a y. So if I have a value of 5 for x and I get a value of 7 for y, there is some sort of relation there. If the relation results in a single value of y for each x value, then your relation is indeed a function. What that means is that if I plug in one value of x, I get one and only one value of y. If I get 2 or more values of y, then it is not a function. So let me give you an example. Here on the board we have a function, and you can see that it is a circle when you graph it. This equation happens to be x squared plus y squared equals 4, and it is going to graph a circle. That is not a function because, just as an example of 2 points, if I plug in 0, 2, or a 0, I can get a negative 2. So I have 2 different values of y when I plug in the same value for x. I plugged in a 0 for x, and I can get either a positive 2 or a negative 2 for my y. Therefore, it is not a function. It does not pass what we call the vertical line test. So let's try another example. Here on your sheet, determine which of the ordered pairs, 2, negative 5, 1, 3, and 2, 1, are in the relation defined by x squared y plus y squared equals 5. I'll go ahead and do the first one with you, and then I'll leave you to do the next 2 on your own. How do you think we would start to figure out whether this value of 2 minus 5 is a part of our function? If you answered substitution, you are absolutely correct. So let's go ahead and substitute in. Everywhere in my function where I have an x, I'm going to plug in a 2, and everywhere where there's a y, I'm going to plug in that negative 5. And let's see if we do get an answer that is part of this relation. In this particular case, my final answer needs to be 5 when I do that. So if I substitute in, here I've got a 2, it's going to be 2 squared times my y value of negative 5 plus my y value squared, so negative 5 squared. Be careful with the parentheses when you substitute in. I encourage students to always substitute using parentheses. Those squares and those cubes and those 4 powers, whenever you have something to an exponent, it can really mess you up if you don't use parentheses. And keep in mind that your calculator is not going to understand that there's a parentheses there if you don't type it in on your calculator. This one is way too easy to use a calculator. We're going to do it all in our heads. But 2 squared is 4, and I had that times the negative 5, and then negative 5 squared is a positive 25, because negative 5 times negative 5 is a positive 25. And does that equal 5? Well, if I do my next step of distributing, we have 4 times negative 5. Of course, that's negative 20, and that gives me negative 20 plus 25 does indeed give me a value of 5. So that tells me that 2, negative 5 is part of this relation. Now let's go to the next one. Go ahead and try to do these next two, 1, 3, and also 2, 1. So if we substitute in the 1, 3, I'm going to have 1 squared, which is 1 times 3, plus 3 squared, which is 9. 1 times 3 is 3. 3 plus 9 is 12. 12 is not equal to the value that I needed, which was 5. Therefore, this is not part of our relation. Now for the final number, if I plug in the 2, 1 value, I have 2 squared, which is 4, times 1, plus 1 squared, which is 1. So I have 4 plus 1, which indeed is 5. So 2, 1 and 2, negative 5, those are both portions of my relation. They do fit. Now the next question is this a function? Well, if you look at the values that we substituted in, we only substituted in 3 values, only 2 of them work. But let's take a look at those 2 values. This, we have a domain of 2, which gave me in my range a negative 5. When I plug in the same value for my domain, a 2, I get a different value for my range, that of a positive 1. That means when I substitute in a single value in my domain, I get 2 possible values in my range. Therefore, this is not a function. It is not going to pass the vertical line test. Now that brings us to the concept of implicitly. The equation x squared plus y squared equals 4, if you recall, we graphed that a little bit earlier. It came out as a circle. We can define this particular relation, because it's not a function, but we can define the particular relation as 2 functions that are acting separately or implicitly. So what we're going to do is we're going to take this equation and we're going to solve for our value of y. On your graphing calculator, you need to enter in equations based on a y value. Y equals something. Now on your graphing calculator, you also have multiple lines where you can graph multiple relations all at the same time. And that's what we're going to do. We're going to come up with the implicit relationships for a particular relation by breaking it into 2 or even more functions. So let's start off by doing this one here. If I were to solve for y, what would be my first step? My first step would be to subtract the x squared from both sides. So that gives me y squared is equal to 4 minus x squared. Now I don't want to know what y squared is. I want to solve for my value of y. So what do I do next? If you said take the square root, you are correct. So we're going to take the square root of both sides. So my y value gives me a plus or minus the square root of 4 minus x squared. That plus or minus is going to be very important because that is giving us 2 implicit relationships. On my graphing calculator, if you hit your y equals button, clear whatever's there. But what we're going to do is we're going to say y sub 1 is equal to the square root of 4 minus x squared. Go ahead and type that into your calculator. The next piece is going to be the negative square root portion. So in y sub 2, have that equal a negative square root of 4 minus x squared. Now once you have that done, you can hit your graphing key and it will graph what appears to be a circle, but it's going to do it in 2 pieces. It's going to do this first graph as the top half of your circle. After it's done drawing that, it is then going to go to y sub 2, and it is going to graph the lower portion of that circle. Now, your graphing calculator may not have it look exactly like a circle because your window isn't necessarily squared. It is a little bit stretched horizontally more than likely, and so it may look more like an oval, but if we were to plug in actual values, we would see it as a circle. So now it's your turn. Try this one on your own. We want to describe this relation of x squared plus 2xy plus y squared equals 1 as implicitly defined functions. This may take a little bit more thought. We are not going to be able to simply solve for y in this case because we have y occurring in multiple locations. We have a y squared and a y. So what do you think you need to do? If you decided that factoring is going to be your first step, you are correct. So try to factor this into two binomials or perhaps even a binomial squared. I'll give you a moment. Once you get that factored, you will be able to then take some steps in order to solve for y. Once you have that done, go ahead and plug those values into your calculator. We'll come back in just a moment and we'll catch up everybody who may be lagging behind. All right, so the first thing I needed to do was to take this particular relation and factor it. So when you factor it, you do end up getting the quantity of x plus y squared equal to 1. Now we need to solve for y. So my next step is I'm going to take the square root of both sides. But keep in mind when I take the square root, I get two possible solutions, a positive and a negative solution. So my x plus y is going to be equal to either positive 1 or negative 1. Now I need to solve for y, so I'm going to subtract x from both sides. So that gives me a negative x plus 1 and a negative x minus 1 as two possible relations or functions. I can then substitute those in on my calculator using y sub 1 as negative x plus 1 and y sub 2 as negative x minus 1. You will see the graph of this particular relation in two separate pieces. So that brings us to the final part of our lesson today, which is piecewise defined functions. We looked at a piecewise defined function just a couple of days ago on your homework. You didn't have to figure anything out other than you needed to recognize some of the differences in the piecewise defined functions. Piecewise defined functions are broken type of functions where you cannot really have values between certain pieces. For instance, on a football field, you can't have 10.5 players on each side. You have 10 players or 11 players. So if you were keeping statistics in certain situations where maybe your team was a very small team, maybe you only had 13 people on the entire team, so people are playing both sides of the line, maybe there's an injury to where at some point you only have 10 players on the field as opposed to 11 players on the field, and you're keeping stats of what happens during those different times. Well, those stats are going to relate between 10 people on the field or 11 people on the field. There's no way you can get stats of 10.5 people because it's simply not possible. The one that we looked at a couple of days ago was dealing with rates on stamps and postage, to where you had jumps depending on how much the object weighed. So if I were weighing something and it weighed 5 ounces, well, if it weighed 5.5 ounces, I was only charged for one particular rate. If I jumped above 6, then my rate also jumped to the next level. Our tax brackets here in the United States are very similar. You make a range of money, you pay a certain rate. Once you get above that range, you're now in the next range, you pay a different rate. So these are what we would consider piecewise defined functions. So piecewise defined functions are functions that model different behaviors over different domain intervals. What is the weight? What is the domain of my weight for my package? Once I get out of one range of numbers for my weight, I pop into the next range of numbers for my weight. So they are very, very specific. And when you do piecewise functions, they are going to tend to jump or have breaks, what we call discontinuous functions. Let's take a look at this example. We have 12 functions that we looked at a couple of days ago. We are looking at this particular piecewise function. So if I do a quick drawing of it, my value of my y is going to be equal to the value of x if my value of x is greater than or equal to 0. So let's just throw in a few numbers. If I start at 0, if I plug in a 0, then I'm in this domain here. And so 0 is 0. So I put a point there. If I use a value of 1 for my x, well, I'm still in this range where x is greater than or equal to 0. 1 is greater than or equal to 0, so x, therefore, is equal to 1. Y is equal to 1. So I go over 1, up 1. Put a point there. If I were to go to 5, well, we're still in this range of numbers here. So 5 is greater than 0, so I plug in a 5 for my x. I get a 5 for my y. So that'd be like right up in here. And so graphing that, it looks something like this. Now let's go to the other portion where x is less than 0. So something like -1. Well, when I use a -1, I have to use y is equal to my negative value of x. So if x is -1, then y is equal to a -1 or +1. So when x is -1, y is +1. If I were to use a -2 for my x value, well, since I am using this equation now because -2 is less than 0, plugging in a -2, I get a -2, which is +2. So I'd be like right here. If I were to use a -5 rather, that would give me -5, +5, and my graph would look something like that. So the question is, what kind of the 12 basic functions does this particular graph look like? If you said absolute value, you are absolutely correct. It is indeed the absolute value. Now I'm going to throw one on the board, and I would like you to try this one on your own. So which two of the 12 basic functions does this graph particularly look like? Well, there are two halves of it. It looks like the right-hand side is maybe a cosine function of some sort, and the left-hand side is a little bit trickier because it is going up as you go from the -infinity toward 0. It is going up, but it's not going up at a constant rate, so it's definitely not linear. I would consider this more of either a logistic or exponential growth. Since we do have what appears to be an asymptote at 0, I'm going to assume that it's probably more of an exponential growth. So on the left side of my graph, it appears to be exponential. On the right side of my graph, it appears to be as a cosine function or maybe a sine function that's shifted. We're going to use the cosine function. So my piecewise function is going to be y is equal to the cosine of x if x is greater than 0, but y is equal to the value of e to the x power if x is less than 0. So that brings us to just a quick review of what we learned in today's lesson. First of all, we learned that a relation is a set of ordered pairs, one value of x giving me a single value of y. Some relations can be broken into two functions. We call that an implicit type of function. And we gave the example of y squared plus x squared is equal to 4. We can solve for y in order to get our implicit relationships there. And in this particular case, we had y is equal to plus or minus the square root of 4 minus x squared. We can then enter each of those implicit relations on our calculators and have them graph without any type of error. The piecewise defined functions are functions that are modeled different behaviors over different domains. When we finished up with that, oftentimes they're going to be broken, they're going to jump, they're going to step, or as we saw in our example with the absolute value, they could simply just change directions or change the way they act at a particular point.